Okay, I think this is video 6. Video 6. Let's keep going here. The number of people waiting in line to enter a stadium can be modeled by the function b, defined by this equation right here. 42 cosine of pi over 30t plus 45 for 0 to 60, where t is the time limit. So from 0 to 60 minutes. So we are using this equation for 60 minutes. Since the stadium opened, based on the graph of the model, which of the following is true? So this one's asking about the number of people is never equal to 0 because the midline vertical shift is greater than the amplitude. Okay, so this is going to be asking us, what does this graph kind of look like? We need to figure out some bits here. So let's sketch our graph. We could just make a wave function. So the amplitude is 42. And let's see. So the amplitude, so from here to here is 42. And from here to here is also 42. So we need to figure out what this midline is, and this midline is 45. So this minimum should be 45 minus 42. So it should have a minimum of some x value followed by 3. Should have a maximum of some x value followed by 87. So that this one, the first one says the number of people in line is never equal to 0 because um, the midline vertical shift, which is 45, is greater than the amplitude. And that's true. The 45 is greater than the amplitude, which is 42. So this is a possible answer. So the number of people in line is never equal to 0 because the amplitude is greater than the midline. The amplitude is not. Amplitude is 42, midline is 45, so this is not a true statement. The number of people in line reaches 0 because the midline, well, it doesn't reach 0. It goes as low as -3, and that's it. So it can't be that one, and that, so it has to be A. It has to be A because it never reaches 0. 31. 31. A large wheel of radius 2 is rotated at a constant rate. The figure provides a representation of the wheel in the xy plane. Great. As the direction of rotation indicated. So it's rotating along these arrows. At time 0 minutes, the wheel begins to rotate. Point P on the wheel is at the start position. So it's starting at a max, or sorry, not starting at a max, it's starting at a midpoint. This is a middle point, so this would be the minimum, this would be the max, this is a middle point, so we're going to be using sine. And it is going up, so it's going to be increasing, so we'll use positive sine. And then, oh yeah, all these have positive sign on it, so that, let's see here. The wheel begins to rotate. Point P on the wheel start, yep, got that. At time 20 minutes, 100 rotations of the wheel have been completed. So, at, we want 1 rotation per minute, so we want, after 120 rotations, we want time per rotation, so we want rotations on bottom. So after 20 minutes, we have 120 rotations. So this means that this is going to rotate quite quickly. So that's going to be zeros cancel out, 1/6 a rotation per minute. Something's not right there. I think I have that upside down. 6 rotations per minute. Oh, 6 minutes per rotation. I think that's what we want. I think we don't want it like this. We don't want minutes per rotation, we want rotations per minute. So we want to flip it, which will be 6 minutes per rotation. So it takes 6 minutes to rotate once. Wait, that's not right. Should take 1/6 of a minute to rotate once. Oh, I flipped. I'm not paying it. This is minutes per rotation. We got it. We're fine. 1 minute per 6 rotations. So 1/6 of a minute per rotation. Sorry, I flipped this one by mistake. Wasn't paying attention. Minutes on top, rotations on bottom. So 1/6 minutes per rotation. 1/6 of a minute, so that's essentially 10 seconds. So if our period is equal to 1/6 of a minute, that means that b is equal to 2 pi over 1/6, which is going to be equal to 12 pi. Keep, change, flip. So flip that, that's 6 over 1, be 12 pi. Okay, times c. A sinusoidal function used to model the y coordinates of the position p as a function of time minutes. Which of the following functions is an appropriate model for the situation? So we all got the amplitudes all the same. And then, so this is all just b. We already figured out b. So I was ahead of the game. Bam, d. Sorry about the confusion there. We want minutes per rotation. That's velocity. So 1/6 minute per one rotation. And that is our period. 1/6 per minute. Next up, the amount of water used each day in an office building is measured in hundreds of gallons. Okay, is modeled by the function defined by 5 sine that one. This whole thing right here. For integer values of t with 0 to 365 days. Okay, so we just want per day. It's not even talking about decimal spots per day. So using actual data over time, it was determined the model underestimates the amount of water used each day by 800 gallons. Based on this information, which of the following functions is a better model for the amount of water used each day in hundreds of gallons? Okay, so this is, bam, that's our function. 5 sine of 0.8 t plus 2 and plus 25. So what this is telling us is that this creates a sine function, right? This creates some wave function. And it's saying that this wave function, this model, underestimates the water used by 800 per day. So this is too small, which means I need all of this to go up. All of this needs to be moved up. And how much do we need to move it up by? Well, we need to move it up by 800 gallons a day, right? 800 gallons. But the unit we're measuring is in hundreds of gallons. So really, we just need to move it up by 8. So what moves everything up by 8? Well, that is going to be your midline. So we need to add an extra 8 to this to make it 33, which should be B. If we're underestimating everything, that means that the actual value should be bigger. Nothing else should change. We just have to shift the whole thing up by 800 gallons. Okay. Let's see what we got here for the next one. Okay, the figure gives 4 points, so C, D, B, and O, and some corresponding rays in the xy plane. Which of the following is true? So, COB. So COB is in standard position. That is correct. So yes, this is in standard position with the initial ray OB. Okay, so this is not true. This is the terminal ray. Initial ray is going to be on the positive x-axis. Okay, so not A. COB is in standard position. Okay, that is true. Initial ray is OC. That is correct. And the terminal ray is OB. That is also correct. So probably B. Just to make sure, let's check. DOB is in standard position. DOB. Well, that is not standard position. So it can't be that. And, oh, this says the same thing, so it can't be that. So it has to be B. B has to be our answer there for 33. 34. Let f be the function given by just sine x. Okay, great. So that's the parent function. The function g has the same amplitude as f, and the period of g is half the period of f. Which of the following defines g in terms of f? So if we have the same amplitude, that means it's still going to be 1. So this f of x is still equal to sine, but it has half the period of f. Well, the period of sine is equal to 2 pi. So the period of g must have a period of pi. And then period does not get plugged in here. There was a lot of errors on the quiz. People were plugging period directly into here, but we need to plug in b, and b is 2 pi divided by the period, which is just 2. So this should be sine 2x. We'll have half the period of sine. So let's see what we got here. Sine 2x. Well, oh, they're doing it in this terms. So f of x should be equal to g of 2x is what we're looking for, or g of 2x. Oh, they did it the other way around. G has the same amplitude as f, and the period of g is half the period of f. Oh, they want it in terms of this one? Oh, f of x should be, this should say g of x. I did that backwards. G of x. G of x should be the same as f of x. My bad. This should say g of x, not f of x. G of x should be equal to f of x, f of 2x. Sorry. So yeah, we have to double the x value, and sine is just f. So it's going to be that right there. Sorry, that was a little confusing. Essentially, g of x is equal to sine of x if it's been doubled. This has to be 2. B is 2. So g of x is f of 2 of x. So it should be C. Okay, another calculator one. Let's see here. The figure gives an angle in standard position with 0.68 pi, and the circle with a radius of 3. Okay. So what is the length of the minor arc of C to B? So it wants the length of the minor arc. So it wants this bit right here. And this is S. This is another theta is equal to arc length divided by radius. And so my theta is 0.687 pi. My radius is 3. And my S is unknown. Multiply both sides by 3, and you should get 3 times 0.687 pi is equal to S, whatever that's going to be. So let's type this in. We should get 3 times 0.687 pi. Bam. And that is equal to 6.475-ish. So it looks like it's going to be C. S, that should be an S, not a 5. S is equal to, what, 6.475-ish, so it should be C. Awesome. Okay, this video is already at 14 minutes, so I'll cut it off and we'll make one more.